Let me download the attendance. Fine. So my screen is visible to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes,
Thank
sir.
you.
Yes, sir.
Yes, sir.
So I'll cover single stage amplifier. From name you can guess it that single stage means here we'll differentiate means if you want to differentiate between multi-stage and single stage means in terms of number of transistors. That's all. An amplifier is one of the essential component in any system, essential component, any system. Maybe theoretically it's fine how amplifier works and what are the components are there, what are the essential circuitry, what about the circuitry, what about the working principle. It's fine. But you must have knowledge about if someone wants to design an amplifier, then what are the tools you have to utilize and for real application if I'm talking about. So that thing also I'll try to cover as much as possible on Friday, coming Friday. Okay. So before that, I would like to cover the basic concepts of single stage amplifier. Okay. So at the beginning of each semester or every semester, I generally include this slide. Okay, and this slide is very crucial for you all. So point is that at the beginning you don't have idea what to do, what not to do. But if you read these lines from the slide, as many as 97% of gadgeting engineers want job either in software or core engineering domain. But only 3% have suitable skills, only 3% to be employed in software or product market, and only 7% can handle core engineering tasks. So what I mean to say, life after BTech is very challenging, competitive. Okay, you are thinking that maybe if I practice some coding, then I'll get the job. It's fine. You have to, but suitable skills. It's not about you will know say C, Java, .NET or some HDL language like System C, Verilog, VHDL. But you must have idea about, because today's industry basically they are following hardware software co-design. What does it mean? If they are getting benefit from hardware for particular implementation or design or target applications, then they are going for hardware implementation. If they are getting benefit from basically software, then they are going for basically software level implementation. But you must have knowledge of both hardware as well as software. It's not about if you study some papers, then there will be a big question about your sustainability. And you'll be frustrated after some days. But at the beginning you have to say, okay, if I want to stay in my core domain, so accordingly you have to prepare yourself. You have to utilize, although we are in virtual mode, but there are lots of open source tools are available. Hello. So please unmute your mobile phone during class. Okay, keep in mind this thing. So you have to keep in mind that you have to utilize each and every moment. What I was talking, although we are in virtual mode, but it is not too difficult to learn new things. Maybe you will be called to campus soon after this semester. But don't forget it. It's very every year 10 to 15 lakhs students, they are getting their BTech degree. And many students are suffering. So think about it carefully, peacefully. Then set your mind and fix your goal. Okay. So now, so in these lectures or next couple of lectures, I'll cover basically real applications of amplifiers, need of amplifiers, single stage amplifier, all the for practical purpose, multi-stage amplifier are mostly used. But based on syllabus, I'll cover single stage amplifier. Then I'll move to classification of amplifiers. Then deep dive into common emitter amplifier, one type of amplifier. There are several types of amplifiers are there. I'll talk about it under this classification of amplifier segment. Then if time permits, or coming Friday, if someone is interested to do something, it is possible with the help of online resources. There are a couple of open source EDA tools are available. Electronic design automation tools are available. You can. Otherwise, it will not. Nothing will happen. What I mean to say. Suppose end of the semester, what you will get the marks. You will get the marks. That's all. But your batch will be suffered. This batch will suffer. Because day one, you are attending classes virtually. It is very difficult. I understand. But you have to prepare yourself. You have to overcome all the obstacles. Then I'll give you one or two mini projects. And with examples, I'll solve 2 or 3 numericals. So last one mini project is basically I'll explain it what you have to do, but you have to do it. No need to submit it to me. So if you are interested to do, you can do it. If you will have any issue, definitely that time I'm always active over phone call or email. Send me an email if you are facing any issues, and maybe some of you may face or you're not able to ask question during the class. They can send a mail. They can call me. Okay, sir, I'm facing this problem. I'm not able to understand this thing. What to do, what not to do. You can discuss with me. Okay, so let's start with real applications of amplifiers. So most of the applications for real applications, one of the essential component is amplifier. Amplifier is nothing. It's a simple device. It consists couple of transistors. Just you have and associated parameters like coupling capacitor, resistors. You have to set the value accordingly based on your target gain, and there may be voltage gain and power gain. What about the gain? Gain is nothing but the output power to the input power. It's a ratio between output to the input. Similarly, in case of voltage gain, output voltage to the ratio of in between output voltage to input voltage. That's the gain. Suppose if you want to, suppose your target gain is, suppose you have to achieve 10 volt. Accordingly, you have to set all the parameters, and that's all. But this is one of the useful circuit and concepts will help you to this circuit with the help of this circuit you can implement a device, which device you can design, you can use, or you can utilize for real applications. And there are a couple of sources. Suppose although it is not part of this lecture, but I'd like to mention that suppose you have one idea based on this amplifier, not necessarily it is based on amplifiers, but if you want to design a circuit or if you want to develop a device, then you want to fabricate it. Suppose I would like to show you one thing. It's all about at the end of the day. So are you able to see this teeny chip? Yes or no?
Yes, sir.
Yes, sir.
So this is nothing but an integrated circuit or IC.
Yes, sir.
So lots of transistors are inserted for a device and for useful applications. And this chip we have developed here at NIT Durgapur, and we have fabricated this chip from SCL Chandigarh. Okay, so if you have a real idea, suppose if you want to implement something new, or if you want to modify the existing circuit, you are welcome. There are a couple of online resources are available also. You can design with the help of open source EDA tools. You can fabricate also with the help of open source fabrication lab. And try to do something. After this semester, you can work under any professor during summer. Do some hands-on experience. And it is possible with the help of online resources. I can guide you if you are interested. But you have to be motivated for that. You have to set your mind. So there are lots of applications. Think about. So today's basically lots of companies and semiconductor companies and VLSI companies, they are basically why there is there are lots of job openings in a semiconductor company because everywhere, automobile, healthcare, defense, medical, data center, multimedia, everywhere there is a concept, the concept of chip or integrated circuit is required to compute something. Okay, so use of amplifier you can use in medical devices, scientific application, automation, military or defense, communication devices, even in household equipments. These are the real applications. We'll talk about it more on coming Friday. Now, need of amplifiers. Why amplification is required? Because we are receiving a weak signal. Or whatever signal we are receiving, strength is very low, but which is very difficult to process it for real application, because we have to increase the strength. So to increase the strength, signal strength, or weak to strong, for that amplification is required. For that amplification is required, or nothing else. Now, an electronic signal. So, for example, suppose think about there are two transmitters. one transmitter, one receiver. Transmitter will transmit some signals, meaningful signals or information in terms of signals. The receiver will receive that signal. But during transmission, the signal strength will change. At the receiver end, when receiver will receive something through antenna, whatever, either in wireless or wired, whatever, media is there. But at the receiver end, you have to use amplifier. Maybe low noise amplifier, or based on your target application, you have to decide. Receiver end, you have to consider amplifier, because you are receiving low strength signal, but which is not, you can't process it for real applications. For that you have to do amplifications. Where exactly amplification is required. So now an electronic signal contains some information which cannot be utilized if it does not have proper strength. It's true. If your signal is poor signal or weak signal or low strength, then you can't use them. Then whole device, whole system, whatever you have developed, or maybe any company they have developed, which will be meaningless. You can't use them for practical applications. So always think about it. It's not about I'm telling something, some equation you are writing and you are thinking, okay, if I do it, I'll get the marks. But don't think like this way. It's not about this subject. So based on your domain, you have to decide. Based on your interest, you have to decide. But everywhere, you must have hands-on experience. You have to perform some hands-ons. Then only you will be able to learn it. Otherwise, it is very difficult. So now, the process of increasing the signal strength, just think about amplification is nothing. You are increasing, you are receiving low strength signal and you are converting it to the high strength signal. And low strength signal is input signal and you are converting the high strength signal, that is output signal. What I mean to say, suppose this is one black box. Okay, this is one black box. Fine. So you are receiving low input signal, and finally you are getting high strength signal. Finally you are getting high strength signal. High strength signals. Okay. So this circuit is known as amplifier, because this circuit is converting, better to say converting low strength signal to high strength signal, or it is increasing the signal strength, and that process is known as amplifications. This process is known as amplification. Means you are magnifying the amplitude of the signals. You are magnifying the signals. And this output signal by input signal, this output signal, sorry. So this output signal by input signal, this output signal by input signal is nothing but a basically gain, nothing but a gain. So for any application, first based on your target application, you have to fix the how much gain you have to achieve. Then the rest of the parameters you have to fix it out. That's all. That's all. For any application, any circuit, based on your target applications, you have to define the specifications of your circuit, and based on the specification you have to design it. Then you can send it to the fabrication lab after following couple of steps. Then fabrication lab will fabricate with your design, and finally you will get this type of chip or IC or device. So almost all electronic equipment must include some means for amplifying signals. All electronic equipments, amplifier is required. Almost. I'm not telling you all equipment. Almost. But based on a syllabus, I'll cover single stage amplifier. But in practical applications, multi-stage amplifiers are utilized or used most of the cases. What about the multi-stage amplifier? So a number of single stage amplifiers, if you consider number of single stage amplifier, if you connect them together in a cascade manner, so this is called basically multi-stage amplifier. Suppose this one is single stage amplifier, this is another single stage amplifier, this is another single stage amplifier. If you connect them together in a cascade manner, it will form a multi-stage amplifier. But to design a multi-stage amplifier, you must have knowledge about single-stage amplifier, how we can build, and what is the working principle, and what are the components, how we can decide the value of the parameters, value of the basically all the components, or that thing you have to understand first. Then only you can go for the next stage.
Sir?
Clear?
Sir, what is the meaning of a cascaded?
Cascaded means series. They are connected in series fashion. Okay, that is known as cascaded.
Okay.
Sir, what is single stage?
I'm coming to you. Okay.
Sir?
Yes.
Sir, how many single stage amplifiers?
Single stage means, suppose this one is one stage, this one is another stage, two stage, this one is another stage, that is three stage. So this whole circuit is basically three stage amplifier. For example, if you are considering, so stage is defined how many transistors are using in terms of transistor, PNP or NPN in case of BJT. So stage you can differentiate the stages in terms of number of transistors. If you are considering three stage, then three transistors are there. Okay, three transistors are there. Fine. So single stage means one transistor will be there, and only you are considering one stage at a time. That is single stage amplifier. If you connect them, it means output of the first stage amplifier is connected with the input of the second stage. Similarly, output of the second stage amplifier is connected with the input of the third stage. It is known as multi-stage amplifier. Yes. Someone was asking something.
Sir, if we added two single stage amplifier, then it is called multi-stage amplifier.
Yes, if your circuit consists of more than one stage, it is called multi-stage. Clear?
Sir, you said you have made an IC direct there at NIT Durgapur. So what are the applications it's being used for?
So what IC we have ICD. So HKM sir has developed a couple of IC or fabricated couple of ICs for earthquake applications. So I have designed a digital IC, and that is for basically that is basically high speed multiplier for high performance computing applications.
Sir, you are not audible, sir.
Sir, your voice is not coming.
I'm not audible.
Now you're
Sir, you are audible.
So now
Sir,
you
you
are
are
audible.
audible, sir.
No, sir, you are perfectly audible,
Just your
sir.
voice is
Sir, you are
cracking.
perfectly audible anytime.
Okay, okay. Let's continue. Okay, let me. Then I'll attend your questions. Okay. Is it okay? So do you have any class after this?
Yes, sir.
Yes.
At what time? 11 o'clock?
11. Yes, sir.
11, sir.
Okay, 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 okay,
Yes,
okay.
sir.
So up to
Have a
this is
class for
fine?
11.
Yes or no?
Yes,
yes,
sir.
sir. You can continue.
Okay, 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 okay. Thank you. So now,
Yes, sir.
yes. Okay. So now let's talk about single stage amplifier. Okay. Then I'll talk about classifications of amplifiers. After that, I'll talk about common mode amplifier. Then I'll talk about how we can implement this amplifier for real applications. Fine. So now, so when only one transistor with one transistor with associated circuitry. Associated means rest of the components we are talking about. Coupling capacitors and resistors and biasing circuits and divider and supply. So when only one transistor is when we are considering for amplification only one transistor to amplify a weak signal, that is known as single stage amplifier. I repeat, when we are considering a single transistor with associated circuitry for amplifying a weak signal, that is known as single stage amplifier. Now, so analyzing the working, as I have already mentioned that this line. So analyzing the working of a single stage amplifier circuit makes us easy to understand the formation and working principle of basically working of multi-stage amplifier circuits. So first you have to understand the single stage amplifier. There are various applications of amplifier. Next is 5G is going on, next 6G is coming. Maybe you don't know in future 5 years down the line 7G may come, okay, in case of communication sector. But it looks like a very small circuit. It's a kind of one, or if you consider another stage, if you consider this is first stage and output of this will be connected with the input of this another stage, it looks like a simple. You can design this circuit with the help of EDA tools. It won't take too much time. Okay, hardly half an hour or maybe 1 hour. But problem is in case of analog IC design, analog circuits, but there is a point of stability or steady state operations. That thing you have to, for that you have to select all the value of all the parameters carefully. That's all. Okay, single stage amplifier, a single stage amplifier has one transistor, and bias circuits and other auxiliary components. So we will apply AC signal as an input. We'll get AC signal as an output, and that AC signal will go for to the another stage as an input. So this is and for any circuit, if you operate it, already you have studied basic principles of amplifiers and biasing circuits, all these things, and BJT and FET. So no need to explain all these things again. So now following circuit diagram shows how a single stage amplifier or single stage transistor amplifier you can remove, or single stage transistor amplifier looks like. So as you can see, for example here, so this is one transistor, So here you can see that it has 3 terminals. collector, base and emitter. Collector, base and emitter. So already you have studied a MOSFET, right? Yes or no?
Yes, sir.
So now can you tell me the difference between MOSFET and this type of BJT or this type of BJT based amplifier?
Sir, carriers, basically their flow of carriers in BJT is both holes and electrons, and they're only holes or either electrons.
Okay, okay. Another in terms of terminal?
Yes, sir, it can be used as a bilateral system in any direction. BJT
Now how
can-
many terminals are there in case of MOSFET?
Sir, two
Four
terminals, source and drain.
Or
Four terminals.
Oh,
Four, sir.
three terminals.
four, sir, four.
Four.
Four, sir.
Four, sir, four.
This is one. Suppose this is source. This is source, insulating layer, silicon dioxide, then gate, and drain. Then this one is substrate, body or bulk, right? That means four
Yes,
terminals are there. Or you can represent like this way also. If it is NMOS, you can connect them together with the ground. Okay. So this is gate, drain, source, and body or bulk or substrate. Okay, fine. Now, so what's the time now? Okay. So now, when a weak signal is given to the base of this transistor, so this is base of the transistor. This is base. This one is collector. This one is emitter. Okay. So look at this arrow. Okay, whether it is NPN or PNP. So this is NPN or PNP? This transistors.
NPN.
So
NPN,
small. Okay, thank you. So when a weak input signal is given, when a weak input signal is given to the base of the transistor, a small amount of base current will flow. This is true. Okay. When weak signal is given, signal is weak. Okay. So small amount of base current will flow. Small amount of base current will flow. Now, due to by convention or transistor action, we can say a larger current flows in the collector of the transistor. Larger current will flow the collector of the transistor. Because already we know, because collector current is beta times of the base current, which means I is equal to beta IB. I is equal to beta IB. So now the collector current increases. Collector current increases. If collector current will increase, then voltage drop across the resistor RC also increases. If collector current increases, voltage drop across the resistor RC increases, which is collected as an output. Now, any of you, can you tell me what you mean by voltage drop? Why it is happening?
The voltage across the RC.
R2, sir.
So why?
So due to flow of current,
Due to flow of current resistance. Voltage.
Due to flow of current, then what?
V is directly proportional to I, sir.
Okay.
There's a loss of energy due to
Loss of energy. Good. Who said? What's your name?
Yes, sir. Abhinanshu Das.
Section
F.
Okay. So now the voltage drop across the resistor RC also increases. If collector current will increase. So please mute your microphone. So which is collected as an output. Fine. So now hence a small input at the base gets amplified. Suppose you are giving small input over here as an input signal, and the signal of the larger magnitude and strength at the output collector. So already I told you the collector current increases, then voltage drop across the resistor increases. Then with that thing we are basically finally collecting. So hence this transistor acts as an amplifier.
Your voice is not audible.
So I think there is a problem at your end. I think so. If 400 students are facing same problem, then problem is at my end. So,
Sir, you are audible.
Yeah, sir,
You can
you're audible.
continue, sir.
okay. So please check your connections, network connections. Okay. So now this transistor acts as an amplifier. Okay. So why it is called amplifier? It is clear? Yes or no?
Yes,
Because we
Yes,
are
sir.
just think about like this way. We are giving low strength signal, and we are getting as an output. Hello, mute your microphone, please.
Yuvraj Gautam, mute your
Yuvraj,
microphone.
Raj. Lost of distraction in class. Okay. Otherwise, I lost my flow. Okay. So please take care this thing from next class onwards. So now, as you already know, what is voltage drop? Again, I would like to repeat it. So as electron pass through the resistance, so they lose energy as they interact with electrons in the conducting material. So conducting materials, they have their own setup. Okay. So as energy is given up to the material, the moving or it gains thermal energy, so its temperature rises. Energy moving up and interacting taking place. Okay, with the electrons in the conducting materials. And temperature as a consequence, what will happen? Temperature will increase. Then the moving electron lose potential energy. So we can say that there is a drop in voltage. So as electrons pass through a resistance, I repeat, they lose energy as they interact with the electrons in the conducting material. So as energy is given up to the material, it gains thermal energy, so its temperature rises. Basically, due to the temperature rises, and the moving electron lose basically potential energy as a consequence. So hence there is a voltage drop. Or drop in voltage. That's the concept of voltage drop. So another important circuit is our practical transistor amplifier is shown below. Practical. So this is nothing but a single stage amplifier. Complete single stage amplifier. As you can see, there are a couple of parameters are there. Apart from NPN transistors, there across the collector there is a resistance that is RC, emitter RE, and across the base here R1 and R2. This is the input signal, and there is an extra capacitor we are adding here, that is C in, and here also there at the output there is another capacitor, that is CC or coupling capacitor, and load is there, output load. And if it is single, this is single stage. If you want to connect it, if you want to consider this circuit for multi-stage, suppose just copy and paste for another state and it will work fine. And if there is any stability issue, we have to set the rest of the parameters. Parameters mean RL, R2, RC, and RD. And you have to define the DC supply based on your target gain or application or specifications. Here on one concept. So this is basic single stage, basic circuits of single stage amplifier. Now and another parameter is that is component is there, that is CE, bypass capacitor. Here in this case, the voltage, let me talk about briefly about voltage divider biasing circuit. So this is circuit, basically part of the circuit. So this circuit basically represents a voltage divider bias circuit. And these are the all circuit currents, because flow of current it's showing, okay, apart from this, and voltage drop that actually what will happen, because they are connected in series, sorry, so they are connected in series, so it is seen that as well as the collector register, please don't unmute your microphone. Whose microphone is on?
So you can do mute everyone from there.
Then you can't tell anything, right? I'll not get a response. That thing I can do. So, okay. So it can be seen that basically as well as the collector register RC. So there is an emitter resistor, that is RE, connected in series through with the transistor. They are connected in series, as you can see. Then the resistor R1 and R2 constitute a voltage divider. Basically, these circuits, these two components are basically introduced as a voltage divider. Why it is called voltage divider? Because it divides the supply voltage. The basic fact is that it divides the supply voltage. Why it is required? To produce the base bias voltage, or to produce the base bias voltage. Now voltage divider, base circuit is normally designed to have voltage divider current, that is I2,
Hello, sir.
to have, just finish this one, then I'll attend you, okay? And to have the voltage divider current I2 very much larger than the transistor base current, that is basically very much larger than the transistor base current, that is IB. Then in these circumstances, VB is the largely unaffected by basically IB, and so VB can be assumed to remain constant. VB can be assumed to remain constant. So VB is basically, it is divided like VCC and so in these circumstances, VB is largely unaffected by IB, and so VB can be assumed to remain constant. So that's why basically it was introduced, or it is called voltage divider, because VCC is power supply into basically this, we are considering this I2, and VCC into I2 divided by total resistance in this part, that is R1 and R2. And why it is important? Because voltage divider bias circuits are normally designed to have voltage divider current, that is I2, and very much larger than the transistor base current. Otherwise, what will happen? So this there is a great impact on this basically input signal. There will be great impact on the input signal. So that's why this type of voltage divider circuit, bias circuit, is required. There will be great impact on the input signal or bias base voltage. So otherwise means this voltage will be more prominent. So to avoid this kind of situation, so this type of voltage divider is introduced. Now, now biasing circuit. So as you can see, so transistors R1, R2 and RE from the biasing and stabilization circuit. So transistor R1 and R2, these are the basically from the biasing and stabilization circuit. These are the mainly introduced for the biasing, from the biasing and stabilization or for stability. Okay, and which help to establish in a proper operating point or question point. Okay, we have to operate our basically device in a particular operating voltage, and for that we are adding extra components. These are the extra components R1, R2 and RE for the stability issues. Okay, for the stability. The input capacitance, as already we have seen, there is extra capacitance, that is input capacitance, coupling capacitance and bypass capacitance. Across the emitter there is a capacitance bypass along with the input signal, that is input capacitance, and at the output there is another capacitance is introduced or included, that is coupling capacitance. So this, what is the role of this input capacitance? The role of the input capacitor is basically this capacitor couples the input signal to the base of the transistors. Input signal, here there is input capacitors, and this input capacitor CE allows only AC signal. Then otherwise what will happen? This DC signal will pass through this path. Then this circuit will not work properly. Okay, and this isolates the AC source from basically R2. Isolate the AC source from the R2. And this, if this capacitor is not present, then input signal gets directly applied, and which changes the bias at basically R2. Which changes the bias at basically R2. So these are the biasing circuit. Biasing circuit basically consists of these R1, R2 and RE components. Then I am talking about input capacitance, that is C in. C in basically blocks signals from source R2 and for the proper functioning or for proper operations. Okay, if capacitor is not present, what will happen? The input signal is directly impacted through this basically this bias at R2 or DC signal at R2. So that's why this extra capacitor is used here in case of single stage amplifier. So another one is coupling capacitor. So coupling capacitor, so this capacitor is present at the end of basically, as you can see from this figure, this capacitor is present at the end of each stage. Okay, end of this circuit, that is known as coupling capacitor, and it couples two stages. Means if you consider basically multi-stage amplifier, then there is a need of basically coupling capacitor. Okay, and this capacitor blocks basically DC signal, because output we want because we are giving AC signal as an input signal, then obviously we will need AC signal as an output signal. Otherwise what will happen, if you are considering multi-stage amplifier, then it will be if you remove this concept of the coupling capacitor, then DC signal will go into the input of this basically next stage amplifier. Then your purpose will not be fulfilled. So this capacitor blocks DC of one stage to enter the other, but allows only, it will allow only AC signal. Okay, so it will act as like a filter. Okay, so now hence it is called the blocking capacitor, because it blocks DC signal, it allows AC signal. That's why it is known as blocking capacitor. Okay, so due to the presence of coupling capacitor CC, the output across the resistance RL is free from the collector's DC voltage. So as this is basically is connected, so this is connected at the output, so it is output RL is basically totally completely free from the collector DC voltage, okay, because it will not allow DC signals, it only allows basically AC signals. So if this is not present, then the bias condition of the next stage will be drastically changed due to the shunting effect of RC, and it would come in parallel to RT in the next stage. So shunting means resistor having a low value of resistance. Such type of resistor is called shunt resistance. If not it will not present, then bias condition of the next stage will be drastically changed, because this output is connected with the input of this another stage. If you are considering multi-stage, then there will such couple of problems will arise, okay, or whatever you are targeting, it will not be fulfilled. So next thing, because already we are in 11 o'clock. Okay, next day we'll talk about rest of the circuits or components in detail. But in practical purpose, basically BGT is no more used. It was introduced in late 1980s or something, or 60s. At the time, but nowadays most of the devices are basically used or utilize